Hey, this is Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson number 13. And this is a lesson about the efficiency of using different types of linear equations, because there's three main different ways, which are point-slope form and slope-intercept form and standard form. And technically, you can also call a recursive formula a fourth way, so technically four ways. So it starts us off with using a formula called I equals PRT, which is simple interest. So this is what you do to calculate how much interest you have to pay when you borrow money. So this is something you will do in real life, which everybody does. You pay interest. When you put money into account, you pay interest. When you buy a car and pay a loan, you pay interest. All right, so you take, it's pretty easy. It's called simple interest because it's actually pretty simple. To find the interest, you simply multiply the principal, that's the P, how much money you borrowed, times the rate, and times the amount of time that you did it, and voila, that is the answer. So if you're paying 11% per year for 2 years times $1,000. So I simply put in my calculator $1,000, and I multiply that by a rate of 11%, which don't forget, percent is always out of 100, so that's 11 hundredths, 0.11, and then multiply that by 2 years, means it looks like you're going to have to pay $220 in interest. So you would have to pay back the $1,000 that you borrowed plus $220 more in interest. All right, so same thing goes for the next question. So if you borrow $6,500, multiply that by an interest rate of 0.125, that's 12.5%. Okay, I put in the wrong thing. So 0.125, and then multiply that by 5 years, and you're going to end up paying $4,062.50. That seems like a lot of interest. Well, 12.5% is pretty unheard of. That's a very high interest rate. $20,000 multiplied by 0.085, because that's 8.5%. And then multiply that by 6 years, and that gives you $10,200. That's pretty much half of what you borrowed. So you have to pay back the $20,000 plus another $10,000 on top. So once again, 8.5%, still pretty high. Pretty unheard of when buying a car or a house to pay that much right now. I mean, hasn't been unheard of in the past, though. So today's lesson, as I mentioned earlier, is about efficiency experts. All right, so we're going to look at, like I said, we're going to look at these four different ways of writing linear equations. We've got y equals mx plus b, slope-intercept form, point-slope form, which you can see, y minus the given y equals slope times x minus the given x. We've got standard form, ax plus by equals c, and then we've got a recursive formula, which simply shows how one term relates to the next term. All right, so verify that the four equations are equivalent. Now, I could spend 10 minutes talking about just that, but I'm not going to do that. But I'm going to very quickly show you that these are all the exact same thing. So in this, I can clearly show you that the recursive is the same as this, because it starts at 1, says it right there, and the rate is times a half. So it's very easy to show you that this and this are the exact same thing. So now, what if I want to show you these things are the same thing? Well, this is something we did a long, long time ago called literal equations. I'm going to solve this for y. And if I was going to do that, I would want to get rid of the x. So subtract x from both sides. So that leaves me with negative 2y equals negative x plus 2. Divide both sides by negative 2, and you get y equals negative 1 half x. 2 divided by negative 2 is negative 1. What did I mess up? So divide by negative 2. Oh, this was negative 2 to begin with. Okay, so that's where I messed up. So this was negative 2 to begin with. Negative 2 divided by negative 2 is positive 1. So, yep, it's the exact same thing. Let me erase that. And I can also prove to you that this is the exact same thing because, well, you can clearly see a half times x is a half of x. Half of negative 4 is negative 2. So once you do that, you're going to get half x minus 2, but then add 3 to both sides, add 3 to negative 2, and voila, you got positive 1. Yes, I just proved that all of these are exactly the same thing. So what this lesson is about determining which one is the most useful for which scenario. So in this job vacuums, Joe sells $500 each month and $20 for each vacuum he sells. Which of these two equations is easier to use for finding Joe's monthly income? Clearly, I think this one's going to be easier because I can put anything in for x and get my answer of y, and I'm done. Whereas this one, okay, so this is the exact same thing. These are the exact same equations, but how am I going to find y? It's not going to be very easy. If I plug X amount of months. If I put a number in for X, I still have to then solve for Y, and I don't want to go through all that. So this one's clearly easier. A tree hugger granola company makes trail mix and carries the mixed nuts. The cost of the candies and trail mix is $2 per pound. The cost is $1.50 per pound. All right, so this time, $2 per pound plus $1.50 per... I'm sorry, $2 per pound for the candies, and the nuts will also cost $1.50 per pound, and the total cost is $540. This one's made for standard form. This one, I don't even really know and understand how this equation is made from this, other than the fact that I could convert this into this. And that would be kind of the same thing. So I would prefer the standard form. So I could just put in X, the amount of candies, the price of and how much candies, and Y is the amount of nuts, and done. Grandma Billings is working on a quote block. So which equation best models the number of blocks in this pattern? So to me, which one best represents the amount of blocks in the pattern is going to be this one, which is the Y equals mx plus b. This one is the exact same thing. The first term is 7 blocks, and every term after that, to find any term, you multiply the previous term. I'm sorry, you're not multiplying, you're plussing. This is adding 6 blocks, adding 6 blocks, adding 6 blocks. So this is true, but what if I was asking you for the 20th pattern? Could you use this to find the 20th pattern? No, because you would have to continue the pattern 17 more times in order to get to the 20th pattern, and that is not very efficient. Efficient means, I should have explained that in the very beginning, efficient means the best way of doing something that does it quickly and correctly. That's what being efficient means. So it doesn't have to just be right, but it also has to be the quickest way of doing it. So that's what you want when you're looking for efficiency. So now we're talking about exponential functions. Yes, these two are the exact same. This is the recursive way. I know the next term is found by taking 3 times the term you are currently looking for, which is the same thing as 3 times the previous term to get the term you're looking for as well. All right, so just 2 different ways of looking at the same thing. So here, Grandma Billings has started a piece of her quilt together and has created the following growth pattern. So looks like we've got kind of a different pattern here. We've got 7, then 14, and then it looks like we've got 28. So clearly the pattern is times 2. So the first term had 7, and everyone after that is found by taking the previous and multiplying it by 2. So what are we trying to do? We're trying to figure out which equation best models the number of blocks in each block and why. Best models the number of squares. This is what I would use to find the number of squares. This is really just the pattern. So I would want to use the explicit because I can, once again, like the last question, put any number in for X and find the answer. All right, so the population of Hot Java Springs in 2003 is estimated 35,000 people, and the annual rate increases 2.4%. Which equation best models the number of people in Java Springs, where T is the number of years since 2003, and why? So, which one would I want to use? I would want to use the explicit question. How would you change the definition of T in the recursive formula to model the situation? Well, in T in this case would have to be years since 2003, the number of years since 2003. So if f of 0 is 35,000, so we're assuming that 35,000 was in 2003. T would have to be the years since then. Okay, so this one, if I want to do the graph, it would start at 2 and it would multiply by 1.8. So this graph starts at 2 blocks, and then you keep multiplying that by 1.8. Now, I don't have a calculator handy on me, so 2 times 1.8 is going to give you, I believe, 3.6. And then multiply that again, it's going to give you, okay, so you need a calculator. It's going to go up like that. It's going to be an exponential function. Which is the best form of graphing? So this one, is this good for graphing? Yeah, kind of, but not really, because like I just mentioned, I would need a calculator. This one is actually going to be better for graphing for me because it gives you the pattern. So usually recursives are actually very useful for patterns because it tells you a starting point. So start at 5, and I'm just kind of eyeballing it here. And then each number after that, well, maybe not so much with multiplication, but each number after that's going to be 0.6 more. So which is 0.6, it means I'm going to add 3 to that 5, which makes it 8. I can do that pretty much in my head. Multiply that by 0.6. Oh, no, 0.6. Okay, 0.6 times the previous. So it's actually going to be decreasing. So it's not going to be 8. It's going to be 3. And then 0.6 of that. Okay, if it was addition, I would definitely, if it was arithmetic sequence, I would go with recursive. Because recursives basically tell you what to do to find the next pattern. So recursives, believe it or not, graphing is the one thing I would say that they are pretty useful for and better than an explicit formula, because they're telling you how to find the next point, so you don't have to actually solve for it. So the homework, I know I'm already at 10 minutes. So basically the homework, they're giving you all 4 forms, so you're going to complete the chart. A, circle the rate of change. So in each row, the rate of change. There's the rate of change here. There's the rate of change. There's the rate of change. That's easy because the rate of change is always multiplied by x. Now the rate of change in point slope is always going to be multiplied by the parentheses. So it's right there. Standard form, the rate of change is a little tricky because the rate of change is actually you have to solve for it. So I can't circle anything here because there really is no rate of change, because in this case, this is going to be, happens to be -3, I believe. So it's going to end up being the number multiplied by x, but it's also going to be divided by whatever's multiplied by y. So I'm not going to circle anything there. The rate of change here, very simple. It's at the end. It's right there. So that was part A. Done. Name the point that describes the y-intercept. So the y-intercept for this equation, keep in mind that these are all the same, is going to be -2. This one's going to be 7, and this one's going to be 3. Now, I know I'm going to answer one of these questions down here, but which one of these formats was the easiest? How was I able to do that so quickly? That would be the slope-intercept. The slope-intercept definitely is the best. Now, I don't want you to do that, so I better do it the same as you. So slope-intercept is definitely the best. And the reason why is because slope-intercept gives you the intercept. That's what it gives you right here at the end. That's the slope, and that's the y-intercept. If I was going to find the x-intercept, what I do know, and this one's going to take a little bit of work because this one doesn't give it to you whatsoever. Neither do these. But the x-intercept is when y is 0. And this one is going to be the easiest when y is 0, for me at least. If I put y is 0 here, I'd have to actually do some heavy work for all of these. But if I know y is 0 here, I know it's going to be 2/3 because 2, when I solve for x, it's just going to take me 1 step. So that's going to be 2/3. If I make y 0 here, that makes it pretty easy. X equals -28. There, I didn't really have to do any work. So if I make y 0 here, that eliminates this. I just divide 9 divided by 2, which is 4.5. So I did standard form to find the x-intercept because it's never going to take me more than 1 step and find the x-intercept, because the y's are going to cancel out. Now, I'm getting pretty high on my time, so I'm basically telling you the answer is what to write right here. I use the standard form, once again, because it's only going to take 1 step. It eliminates part of the equation. Which equation do you prefer to finding the rate of change? The rate of change, honestly, you can go with this one, or this one. It really doesn't matter because they are all blatantly right there in front of you. It's right there, right there, right there. Maybe you want to go with recursive, or maybe you want to go with slope-intercept. It really doesn't matter. That's your choice because anything except for standard form is acceptable for question number 9. So it's basically up to you. All right, I know I'm at 13 minutes, and that's more than normal. Thanks for watching. Please give it a like if I helped you learn something, and definitely subscribe if you haven't done so already. Have a great day.